In question 2, we have a car that is slowing down. So if I put, here's my car and it's moving this way, I'm going to say that the direction it's moving is positive and the other direction is negative. So a couple things to know is that the acceleration is going to be negative and that my net force is going to be negative. There's a few things I could do about this information. One, I could solve it graphically. Let's try this for a second. If I solved it with a VT graph, then I could go and say, all right, or if I'm just representing the motion at this point, my velocity starts at 20 and ends at 5. And the amount of time that goes by, and this is meters per second, and time is measured in seconds, and the amount of time that goes by is 4 seconds. Here's what my line would look like. Okay, and we can think about this and we can say, oh, I know that the slope is equal to the acceleration and that the area is going to be equal to my displacement. So the question asks, first of all, it says determine the net force on there. Well, what's the relationship between the kinematics and the net force? Well, the net force, a little bit too big, the net force is equal to the mass times acceleration, and I can use my kinematics over here to figure out what acceleration is. Okay, so what's acceleration going to be? The acceleration will be, well, it's the rise over the run, and it goes downhill, so it's actually rises minus 15 divided by 4, so I get minus 3.75 meters per second squared. And just a quick reminder that this negative has to do with the fact that it's moving to the right and slowing down. So in other words, it's accelerating in the negative direction. Now some of you might have also solved this using our big 5, our kinematics. So thinking about this, we could have written VI is equal to 20 meters per second, and the final velocity is equal to 5 meters per second. And we said, oh, okay, time goes by, delta t is 4 seconds, and we could have said, I wonder what acceleration is. So if you have your constant acceleration formulas and you were to look at that, one way to look at it is the one that does not have displacement, doesn't have delta x in it. So I guess that would be some version of this, where acceleration is delta v over delta t, and this would be vf minus vi all over delta t. So really it works into exactly what we did here. It's going to be 5 minus 20 all over 4, and you see that ends up being exactly what we did before, that minus 3.75 meters per second squared. Okay, so to solve now the average net force, let's go over here and we'll say F net is going to be equal to the mass of 2,000 kilograms multiplied by this acceleration of minus 3.75. We multiply those together and I think we get minus 7,500 newtons. So a couple things. One is that the negative sign means that it's in the leftwards or opposite the direction that we're moving. It's the negative that we defined up here. The other one that might bother some people is that it says average net force. And how do we figure out this average net force? Well, looking at this velocity time graph, I drew it as a straight line because it said uniformly, that it's slowing down uniformly. In other words, it has a constant acceleration, and this is going to be a straight line. If you were braking in your car and you didn't brake uniformly, and it was kind of like this line was kind of going up and like this, then it would make sense to say the average force. So average net force in this case isn't going to make any difference into our calculations. In fact, this net force, because this word uniformly is there, this is actually a constant net force. If it was slowing down not uniformly, it would still have the average net force, but it might be varying, like they may have put their brakes on hard to begin with and then eased off at the end or something like that. Okay, so I hope that is helpful. The last one says how far the car traveled while slowing down. So looking at it graphically, looking at the VT graph, we could say, what is this area? And just a reminder that you would have to solve for that rectangle piece at the bottom as well as the triangle piece on the top. And if you're going to solve it using our kinematic equations, then we would look for one that has delta x in it, and there's almost any formula you can use except for the one that we just used that didn't have delta x. So I would maybe take vi plus vf over 2 times delta t, and so we get 5 plus 20 divided by 2, and then times 4, and then my final answer would be 50 meters. If you were solving it using the velocity time graph, then this area here would just have been, 4 times 5 would be 20 meters, while this area over here would be 1/2 times the base, which is 4, multiplied by the height, which is 20 minus 5, which is 15. That's 2 times 15, that would be 30 meters. So 30 plus 20 would also give you the same 50 meters. Oh, there, that same 50 meters at the end. Okay, so that's question 2. I hope that was helpful.